Now I'm going to show you a diverging lens, and I'm going to find the position of the image produced by this lens, and then I'm going to explain how the image is real or virtual. So first, our focal length is going to be -10 centimeters, and then our P is going to be 13 centimeters. We are looking for Q, and we are looking to find the magnification.
First, this is the objects, and then that's the focal point. I will first draw the first ray, which is going to be parallel to the axis, and then it appears to come from the focal point on the same side, but you will have an oblique dashed line, which will be indicated, and then going straight through will be a solid line. Next, I'm going to draw a ray that's going straight through the lens with a solid line. And the third ray I'm going to draw is going to go to the middle of the lens, and then it's going to go parallel backwards and parallel straight through. Then from that angle where it hit the middle, it is going to hit the opposite focal point with a dashed line.
Now to figure out the math and how to get either the distance from the object, the distance from the image, or the distance of the focal length, you need to do 1 over P plus 1 over Q equals 1 over F. This is very similar to the convex and concave formulas, except P represents the distance from the lens to the object, Q is the distance from the image to the lens, and F is still the focal point. Now to find the magnification of the lens, you do M is equal to the image height over the object's height, which is also -Q over P, which is the same formula that it was for convex and concave, except now Q is the distance from the image to the lens, and P is now the distance from the object to the lens, and it is still negative. And as I do the math to figure out the Q value, I find the reciprocal of it, which equals -5.65, and then I will put that number into my magnification equation, and then my magnification will be equal to 0.434. A diverging lens creates a virtual image of a real object placed anywhere with respect to the lens. The image is upright, and the magnification is always less than 1, that is, if the image is reduced. Additionally, the image appears inside the focal point for any placement of a real object. And because a diverging lens only has one case, this is the only image that can be drawn.